For activity 5.5, we're going to be going over molecular formulas. Okay, so just as a reminder, the empirical formula is going to give the ratio of atoms in a molecule, whereas the molecular formula actually tells us the number of atoms in the molecule of that substance. Okay, so for example, we have the substance glucose. Okay, glucose has the molecular formula of C6H12O6, but the empirical formula, the ratios, is C1H2O1. Okay, so these can be reduced down, each divided by 6 to give us the empirical formula. Okay, so the molecular formula tells us how many is in the actual substance. So glucose is going to have 6 carbon, it's going to have 12 hydrogen, and 6 oxygen. Okay, so to find molecular formula, when we are given the empirical formula, we also need to know the mass of 1 mole of that substance, so the molar mass. Okay, so in order to find molecular formula, we need to be given the empirical formula and we need the molar mass of that substance. Okay, so if we have the molar mass of a compound is 181.5 grams per mole and the empirical formula is C2HCl, what is the molecular formula? Okay, so they've given us the empirical formula. There's 2 carbon, 1 hydrogen, and 1 chlorine. Okay, and they've given us the molar mass, so we can go ahead and solve for the molecular formula. Okay, so step 1, we're going to find the molar mass of the empirical formula. Okay, so to do this, we look at how many of each of the elements is in the compound. Okay, so here we have 2 carbons, so 2 times the atomic mass, which can be found on the periodic table, so 2 times 12.011, plus hydrogen, there's only 1, so 1 times the atomic mass of hydrogen, plus there's only 1 of chlorine, so 1 times the atomic mass of chlorine, which is 35.45. So when I multiply and then add these all together, I get 60.48. Okay, step 2 is we're going to divide the molar mass of the compound, which is given to us in the problem, by the mass of the empirical formula. So 181.5, which is the molar mass of the compound they gave us, divided by the molar mass of the empirical formula that we just calculated, so 60.48, and we're going to get 3. The last step is to multiply the number from step 2 by the empirical formula subscripts. Okay, so we're going to take the 3, we're going to times it by the 2 carbons, so we're going to end up with 6 carbon. Okay, 3 times the 1 hydrogen, so we're going to have 3, and 3 times the 1 chlorine, so we're going to have 3. So the molecular formula for this compound is C6H3Cl3.
This practice problem states muscle fatigue can result from the buildup of lactic acid resulting from over-exercising. The percent composition of lactic acid is 40% carbon, 6.67% hydrogen, and 53.3% oxygen. What's the molecular formula for lactic acid if its molar mass is known to be 90 grams per mole? Okay, remember to find molecular formula, we need both the molar mass, which they give us here, and then we also need to know the empirical formula. They didn't give us the empirical formula, but they gave us the percent composition, which we can utilize to find the empirical formula. So that's the first step we need to do. Okay, so when finding the empirical formula, using the percentages, first we need to convert it into grams. So 40 grams of carbon, 6.67 grams of hydrogen, and 53.3 grams of oxygen. Okay, then we need to convert it to moles. So we're going to times it by 1 mole over the atomic mass, which can be found on the periodic table. So for carbon, it's going to be 12.011. For hydrogen, it's going to be 1.008. And then for oxygen, it's going to be 15.999. Okay, and so whenever we go through and divide, these are the answers that we get. Okay, and then the last step for that step is to circle the lowest. We actually have two that are the exact same at being the lowest, but this will be the number that we divide each of them by for the next step. So we're going to divide each of them by the lowest, so 3.33. And we'll get 1. When we round this one, it'll be 2 and 1. Okay, so our empirical formula is going to be C1H2O1. Okay, so now we have the empirical formula, and they've given us the molar mass in the problem, so now we can calculate out the molecular formula. Okay, so first thing, we need to find the molar mass of the empirical formula. So there's 1 carbon, so 1 times the atomic mass, which is 12.011, plus there's 2 hydrogens, so 2 times 1.008, plus there's 1 oxygen, so 1 times the atomic mass of oxygen, which is 15.999. Okay, when we multiply and add these all together, we are going to get 30.06 or 26 grams per mole. Okay, so now we have the molar mass of the lactic acid and the molar mass of the empirical formula. So now we're going to divide the molar mass of the molecular formula, so 90 divided by the molar mass of the empirical formula, so 30, and we get 3. The last step is we're going to multiply this number that we found by each of the subscripts within the empirical formula, so 3 times 1, 3 times 2, and 3 times 1. So our resulting molecular mass, or molecular formula, is going to be C3H6O3.